So we'll start strength of materials or mechanics of solids or solid mechanics. So in this subject, we'll be developing the basic knowledge of strength of materials, which will be enabling us to solve real life engineering problems. So basically in civil engineering or mechanical engineering applications, we deal with real physical systems. And real physical systems consists of materials. But the type of cases we have considered in engineering mechanics, we did not consider the material properties. We just considered the element, but we did not consider anything about the material properties. So we considered the object as rigid. But in strength of materials or mechanics of solids, we'll be considering the physical system and we'll be considering the material properties as well. And we'll be analyzing the physical systems. So we deal with the deformable bodies as well. So with respect to the civil engineering and mechanical engineering applications, if we classify mechanics now, we'll be getting engineering mechanics, solid mechanics or strength of materials, and fluid mechanics. So in engineering mechanics, generally we consider the body as rigid and we see the external effects on the rigid body. In solid mechanics or strength of materials, we consider the body as deformable because it can deform, and we see the internal effects as well. In fluid mechanics, we deal with those elements which deforms continuously. So in strength of materials or solid mechanics, we'll be understanding the behavior of materials in different types of systems. So when we are dealing with deformable bodies, we need to understand the deformation of deformable bodies. So basically we classify it in two different categories. One is elastic deformation and another is plastic deformation. So when we are applying load on the body, it is deforming. Now after the load is released again, the type of deformation which can recover is called elastic deformation, and the type of deformation which is not recoverable is called plastic deformation. So plastic deformation is that deformation which the body cannot recover even after unloading. So when we talk about load, we need to know about different type of forces which are applied on the body. So basically we classify the forces applied on a body in two different categories. One is body force and another is surface force. Body force are those forces which are acting on the body, and surface force are those forces which are acting on the surface, like surface traction. So let's talk about a few categories of forces. So if we talk about gravitational force, even if I'm not touching the ground, even if I'm jumping in the air, then also the gravitational force is acting on me. When we talk about inertial forces, we talk about static and dynamic inertia and the force with respect to that. Then we have the magnetic force. There also we do not need to touch it. And now comes the mechanical force, where we definitely need to touch the body to apply the force. Basically in this particular subject, we'll be dealing with the mechanical forces. So when a body is subjected to the mechanical forces and we are interested to know about the forces in the body, we see what's happening within the body. To do that, we make the body free and we draw all the forces and reactions in the free body, and we call it free body diagram. And we see the magnitudes and directions of all the forces, including the applied forces, the reaction forces, and all the type of forces which are acting specifically on the body. So we'll start with the material properties. We'll understand the concept of stress. We'll talk about simple stress and strain, shear force, bending moment, shear stress, bending stress, torsion. We'll learn about theories of failures, deflection of beams, columns and struts. We'll do the theories, we'll solve the numerical problems. After the basic topics, we'll be also going for the advanced topics, and all of this we'll be doing in a short, simple, interesting and compacted manner. Let us know if we are missing something. Thank you.